Welcome to eDay20. Today is Tuesday. We are going to be doing IXL U4 in Algebra 1, but you only need to go to 60%. Today we're going to be graphing systems of equations using slope-intercept form, but then we need to talk about the number of solutions. No solution is when the lines are parallel, meaning they do not intersect. One solution will be where the lines intersect at one point, and infinitely many solutions are where the two lines are the same, so they're right on top of each other, and they have every point in common. First thing we need to do is graph each line. So our first one is y equals x minus 5. Remember your slope-intercept form, y equals mx plus b. Your y-intercept is -5, and then your slope here is 1. When we graph in y equals mx plus b form, the first thing we do is plot our y-intercept on the y-axis. And that y-intercept is at -5. Then we have a slope of 1. For slope, we want to write it as a fraction, so 1 over 1. It is positive, so we're going to go up to the right. We're going to go up and to the right. So up 1 and to the right 1. And then IXL will automatically connect your dots for you and add in your arrows. The next one is y equals 1/3 x minus 3. This is your y-intercept, and we always start plotting the y-intercept on the y-axis. Then our slope is 1/3. It is positive. When it's positive, you're going to go up, and then we always go to the right. So it's going to be up 1 and to the right 3. And then when we connect these dots, our graph intersects. When your graph intersects, you don't need this time to find what the intersection point is. You just need to know how many solutions. And when there is one intersection point, when they cross, there's going to be one solution. Our next problem, if you look closely, these two equations look exactly the same. That means they are going to be the same line, meaning they have every single point in common. Now, unfortunately, you just can't click on infinitely many solutions. They want you to also graph it. Let's go ahead and practice graphing. Y equals mx plus b. We always plot the y-intercept first, and that y-intercept is at -5 on the y-axis. Next, we're going to look at our slope. Our slope is -1, and to write it as a fraction, we'll put it over 1. Because it's negative, we are going to go down, but we always will go to the right. So from our y-intercept, we're going to go down 1 and to the right 1 to plot our point. And then we'll connect our dots and create our line. If you look at the next problem, the next equation is exactly the same. It has a y-intercept of -5 and a slope of -1 over 1. So when we go down 1 and over 1, we land at that point. Because these lines are graphed, are the same exact line, not only do they have those 2 points in common, they have every single point in common, and that's why we call it infinitely many solutions. Our next problem, let's go ahead and graph this in y equals mx plus b. First thing we're going to do is plot the y-intercept on the y-axis at 3. Our slope is -5, and to write it that as a fraction, we'll put it over 1. Negative means we're going to go down, but we're always going to go to the right. So from our point, we're going to go down 1, 2, 3, 4, 5, and then over 1. And we will connect those dots to create our graph. Sometimes when you're graphing and writing in your slope, it's helpful to kind of draw that little triangle that shows that we went down 5 and to the right 1. Now let's look at the next equation that we have to graph. This is also in y equals mx plus b, but notice this time the y-intercept is at -3 versus a +3. And then our slope is -5/1. So we're going to go down 5 and over 1 and plot that point. And then when we connect those dots, what do you notice about those two lines? Those two lines are what we would call parallel. They do not intersect. And if they do not intersect, that means they will not have a point in common, so there will be no solution. Now I have one more equation for you, and this is one where we're going to have to solve for y. I have you stopping at 60% because that means you only have to solve for y a few times. To solve for y, we want to get our y by itself, and the very first thing we do is move the x. If that is a positive x, we are going to subtract it to the other side. When you drop down, make sure that you're dropping down that negative sign. Negative y, write your x first, so negative x plus 3. So on that right side, we have negative x plus 3. Now in front of the y is really a -1. So we want to divide everything by a -1. That will get our y by itself. Now over here, a negative divided by a negative is a positive. So we have a positive x. And then for the next one, 3 divided by -1 is -3. Graphing this equation, our y-intercept is -3, but our slope is 1. Let's plot our -3 on the y-axis. With a slope of 1, it's positive. That means we're going to go up and to the right, so up 1 and to the right 1, and then plot your point. And when you plot your point, you're going to connect your dots. That triangle is not really there, it's just to help you create that slope as you're graphing. Looking at our next equation, do you notice anything about the two equations? Those two equations are exactly the same. They both have a slope of 1 and a y-intercept of -3. Y-intercept of -3, a slope of 1. That means they are the same line. And when they're the same line, that means they have infinitely many solutions because they have infinitely many points in common. Now, like I said, you're going to stop at 60%. You will have a few problems where you have to solve for y. You'll need to do that on a separate sheet of paper to put it into y equals mx plus b. If you struggle at all, please contact us and we will Zoom with you. We are on Zoom every day at 11:30. Mrs. Exline, Mr. Knitter, Mrs. Butler, myself. But if that time doesn't work for you, just email us or send a message on Remind and we will set up a time with you to work with you on this IX.